Hello everyone, welcome in a Rose project. Myself Patil AS from SGM College Karad. At the previous lecture from chapter elements of group 16, 17 and 18, we completed the reactivity of the elements of group 16, 17 and 18 towards the oxygen, towards the halogen and towards the metals. Now in this lecture we study about the oxyacids and the oxygen, also some different compounds of the oxygen. The oxyacids of the sulfur are the sulfuric acid, sulfurous acid as well as the di or pyrosulfuric acid. The structures of the sulfuric acid or sulfurous acid or the pyrosulfuric acid are drawn here. The structure, that means our S8 ring of the rhombic sulfur as well as the chair form structure is given. The peroxy monosulfuric acid, that means H2SO5, that means 2 hydrogens, 6 oxygen and the 1 sulfur, that means pyroxy monosulfuric acid. The structure of these oxyacid is given here. Also the peroxy disulfuric acid H2S2O8 is given below, and the thiosulfuric acid, that means H2S2O3 is given here. Now the next, oxyacids of the halogens. The halogens also form the different types of oxyacids. Only 4 oxyacids have the isolated in the pure form, that means hypofluorous acid HOF, the perchloric acid HClO4, iodic acid, that means HiO3, and a metaperiodic acid, that means H2iO6. The others are stable only into the aqueous solution or in the form of their salts. The acid strength of the halogen oxyacids increases with the increased oxidation state of the halogen. For example, that acid strength increases from HClO. A weak acid, that means the K value is 3.5 into 10 raised to minus 8 to the HClO4, that means our perchloric acid, towards the perchloric acid. It is the very strong acid. The value of K is the greater than that of 1. The oxidation state as well as the name of these oxyacids of halogens are given here. The oxidation state goes on increases, that means +1, +3, +5, +7 for the perhalic acid are given here. In this whole table we understand the different generic names as well as the oxyacids of the fluorine as well as the chlorine and the oxyacids of the bromine and iodine. The structure of oxyacids which are formed by the chlorine, that means HOCl, is given here, that means hypochlorous acid. These hypochlorous acid, that means 1 hydrogen, oxygen and a chlorine, they are bonded like this, HOCl. Chlorous acid, that means HOClO, or we write this formula as HClO2, HOCl and O, that means O2, this H and a Cl. Chloric acid, that means HClO3, HClO3. Perchloric acid, HClO4, HClO4. After the oxyacids, what are the oxygen? And there are different compounds or oxygen are given below. Dioxygen, that means O2. How we get that dioxygen? There are different methods of preparation. Laboratory method, into the laboratory, when we give the heat to the oxygen containing salts. These salts, such as the chlorate or a nitrate, when we give the heat to that of a chlorate or nitrate, then they give oxygen. Here KClO3, when this salt on heating we get KCl and the O2, that means our dioxygen. Also by the thermal decomposition of the oxides we get the dioxygen. Here the Ag2O, that means our oxide, metal oxide. Here we take Ag and Hg as a metals, and these metal oxides on heating, that means thermal decomposition, we get the dioxygens. Also from the PbO2 on heating we get PbO, lead oxide, and the oxygen. Also we get by the electrolysis process. Into the electrolysis process, dioxygen is prepared on the large scale by electrolysis of water. From the water we get the dioxygen. When hydrogen is liberated at the cathode and oxygen at the anode. See here, from the twice H2O on the process of electrolysis we get the hydrogen gas as well as the dioxygen. Also we get by the industrial method, dioxygen is obtained from the air by first removing carbon dioxide and water vapor. The remaining gases are liquefied subsequently. This is followed by the fractional distillation. Now from this process we get the dinitrogen as well as the dioxygen. By decomposition of hydrogen peroxide in the presence of a catalyst, we use here the catalyst, that means manganese dioxide, then we get the dioxygen. Twice H2O2, our peroxide, on heating we get the water molecule as well as the dioxygen. There are different physical as well as the chemical properties of dioxygen. First we discuss the physical properties. Dioxygen is the colorless, also it cannot have any odor, that means it is odorless gas. Dioxygen, it is a soluble into the water, 3.8 cm cube of O2 dissolve into the 1000 centimeter cube of the water at the 293 Kelvin. A small amount of dissolved dioxygen is sufficient to sustain marine and the aquatic life. That means into the 1000 centimeter cube of the water, only 30.8 cm cube dioxygen will be dissolved. It liquefies at a 90 Kelvin and freezes at the 55 Kelvin. Oxygen has three stable isotopes, that means O16, O17 and O18. Molecular oxygen O2 exhibits the paramagnetism. These are the physical properties of dioxygen. Now the next, these are the chemical properties of dioxygen. From that chemical properties, the first one is the reaction of this dioxygen with metals. When this dioxygen is react with the metal, then the oxides we get. When calcium is react with this dioxygen, then we get the calcium oxide. Aluminium also gives the oxide, Al2O3. That dioxygen is also react with the non-metals, carbon, phosphorus, like that. When this dioxygen is react with the non-metal, also we get the oxides. That means carbon when react with the dioxygen, then we get CO2. Phosphorus on react with the oxygen, dioxygen, then we get P4O10. That means E2O5 form of the oxide. different compounds also react with the dioxygen. ZnS plus O2 give rise to ZnO, that means oxide we get here. Also sulfur dioxide is the byproduct of this reaction. When methane is react with the dioxygen, we get carbon dioxide as well as the water molecule. Sulfur dioxide on react with the dioxygen, then we get the sulfur trioxide. HCl on react with dioxygen, then the chlorine gas will be liberated, also give water molecule. There are different uses of dioxygen. The dioxygen is used as a respiration process into the animals as well as the aquatic life, sustain animals and the aquatic life. The dioxygen is also used into the manufacturing of steel. The dioxygen is used into the oxyacetylene flame for the welding and the cutting of the metals. Oxygen cylinders are widely used into the hospitals. High altitude flying and the mountaineering, the process, they use the dioxygen cylinders. Dioxygen is a combustion agent, that means it is used into the combustion of fuel. For example, hydrogen in the liquid oxygen provide tremendous thrust energy into the rocket. Now some simple oxides. A binary compound of the oxygen with the another element is called as a oxide. Oxide can be classified into different types, that means acidic oxide, basic oxide, amphoteric oxide and natural oxides. Acidic oxides and oxides which dissolve in water to give an acids or react with a bases to give a salt is called as the acidic oxide. That means when these oxides are react with any acid or base, they give the salt. SO2 when react with the water, H2SO3 we get, and that sulfur trioxide again react with the NaOH, then Na2SO3, Na2SO4 salt we get here. Generally oxides of non-metals are acidic oxides. The second one of the basic oxide, these are oxides which dissolve into the water to give a base or react with an acid to give a salt. That means if we comparing the acidic oxide and basic oxide is dissolved into the water and gives base. But in case of acidic oxide, it dissolves into base and it gives acid. And when they react with acid, they gives a salt. But in case of acidic oxide, when they react with base, they gives the salt. These are the difference between acidic oxide and basic oxide. Here there are different examples of basic oxides are given below. Next will be the amphoteric oxide. The oxides which react with the base as well as with an acid to give a salt. In case of amphoteric, they react with both. If they react with acid, then they give a salt. Or if these oxides when react with the base, they give also salt. For example, acidic aluminum oxide is react with the sodium hydroxide in the presence of water, then the salt is obtaining. Also the basic aluminum oxide, it react with the HCl, that means with acid, then it gives the salt. And last one is the neutral oxide. These oxides neither acidic nor basic. Such a type of oxide are considered as a neutral oxides. For example, carbon monoxide, nitrogen monoxide, dinitrogen oxide. These are the neutral oxides. Now the next is the ozone. Ozone means O3 In an allotrope of oxygen, ozone in the upper atmosphere absorbs the energy in the form of ultraviolet light and changes into the atomic oxygen, which combines with the molecular oxygen to form a O3. That means at atmosphere oxygen is present. They absorb the UV light coming from the sun and then they gives the ozone O3 molecule. How we prepare the ozone? That means O3 is getting from the O2 dioxide. There are different physical properties of the ozone. Pure ozone is a pale blue gas, dark blue liquid, and a violet black solid. Into the three state we get the ozone. Ozone has the characteristic smell. When inhaled into concentration above 100 ppm, it causes nausea and the headache. It is diamagnetic in nature. These are the physical properties of ozone. The next point is the chemical properties of the ozone. From that, first chemical property is the oxidizing property. Ozone is a powerful oxidizing agent as it easily decomposes to liberate nascent oxygen. Ozone gives the nascent oxygen here on a decomposition process. O3 gives O2 as well as the O. Ozone oxidizes lead sulfide to lead a sulfate and the iodine ion to the iodine. Iodide ion to the iodine. See here that lead sulfide is react with the ozone. Then we get such a type of reactions from these processes. These all processes are considered as the oxidizing property of the ozones. From the bleaching property, ozone acts as the good bleaching agent due to its oxidizing nature. It is a colored matter or colorless matter. Ozone bleaches in an absence of moisture, so it is also known as the dry bleach. Now reducing property. Next one is the reducing property. Ozone reduces peroxide to oxide. That means H2O2 when react with the ozone, then we get the oxides. The next one is the ozone depletion. Thinning of ozone layer in upper atmosphere is called as the ozone depletion. The ozone layer in the upper atmosphere absorb the harmful UV radiation comes from the sun, thus protecting people on the earth. That means that ultraviolet rays will be harmful to the human being. Depletion of ozone layer in the upper atmosphere is caused by the nitrogen oxide released from the exhaust system of a car or the supersonic jet aeroplanes. That NO when react with O3, that means ozone, then nitrogen dioxide gas will be formed. Depletion, that means thinning of ozone layer, can also be caused by the chlorofluorocarbon, that means fluorines used in a aerosol and refrigerator and their subsequent escape into the atmosphere. The depletion of ozone layer has been most pronounced in a polar region, especially over Antarctica. Ozone depletion is the major environmental problem because it is increased by most amount of ultraviolet radiation that reaches Earth's surface, thus causing an increase in rate of skin cancer, eye cataract, and the genetic as well as the immune system damage among the people. These are the harmful effects by the ozone depletion. The structure of ozone is the angular molecule. The two O O bond having length into the ozone molecule are identical 128 pm and the bond angle is 170. It is a resonance hybrid of a two conical form. The bond length is the 129 pm and the bond angle is 170. Now some uses of ozone. Ozone is used for air purification at crowded places like cinema halls, tunnels and a railway etc. In a sterilizing drinking water by oxidizing all germs and bacteria. The ozone is also used into the bleaching lorry, oils, starch, wax and the delicate fabric such as the silk. In the manufacturing of synthetic copper, potassium permanganate, the ozone is used into the manufacturing of that. These all are the uses of ozone. These are the compounds of the oxygen we will complete here. Thank you.